Alright, we're going to finish up the example that got cut off here in 5.1, and then go ahead and finish the last example as well. Where we left off, we now have our expression with all positive exponents, and still a positive exponent on the outside of the parenthesis. We can now use the product rule to simplify what's inside the parenthesis, clean that up a little bit before we apply the power of 2 that's on the outside. So the product rule, remember, is if we have 3 factors of a times 5 more factors of a, we add those powers up and get 8 factors of a. So that's going to be equivalent to saying in our numerator 15 a to the 8th. And then in our denominator, we have 5 as our coefficient, and then b to the 7th times b to the 5th. Well, again, we add the exponents, giving us a b to the 12th power. So that simplifies our parenthesis. Now we can apply that power of 2 that's been sitting on the outside of the parenthesis this whole time. So we have to apply that power of 2 to every single factor that is inside the parenthesis. The 15, the a piece, the 5, and the b piece. So we're going to have 15 squared. I might as well get in the habit of putting parentheses, because if it was negative, you'd want to put that in parentheses. We have a to the 8th to the 2nd power, or squared. We have 5 squared, and we have b to the 12th squared. Okay. The numbers that we are squaring, 15 and 5, we can go ahead and just square those like regular numbers. However, when we have the variables with a raised to a power, then raised to another power, that's the power to a power rule where we have to multiply to simplify those expressions. So, this is going to equal 15 squared. 15 times 15 gives us 225. 8 times 2 gives us 16, so we have a to the 16th power. 5 squared, 5 times 5 gives us 25. And then 12 times 2 for our exponents on the b gives you b to the 24th. Okay? And here we would be done, except we can reduce our coefficients out front, because 225 is divisible by 25. It actually, if you divide these two, it would give you 9. So that, how we would write that is we'd write 9 would be our numerator, a to the 16th over b to the 24th. Okay, 25 goes into 25 one time, 25 goes into 225 9 times. So we could have a 9 and a 1 down below, but just like with any fraction, if you have it over 1, you can just write it as the whole number. Alright. So that finishes up that example that had gotten cut off. Now let's finish up this last example here. Okay. Over here to the left, cover this one up so we're not looking at that example anymore. And now we have not fractions, but again something involving negative exponents. So on this problem, well, actually, let me keep the other one open so we can kind of compare what we did. When you have a fraction that has a negative exponent on the outside, you want to flip your fraction, but then simplify inside before you start applying a power of 2 to everything. Over here with our example, when we have things written kind of horizontally with negatives, I would apply the negative exponent first before you start moving things around, making fractions or flipping where fractions would be, and so on and so forth. So I would apply this negative 3 exponent to this parenthesis on the left before I started doing anything else. And that is the only parenthesis we'd have to apply it to, because the negative 3 exponent is not attached to the second parenthesis, just the first one. So you want to apply that negative exponent first. That's where I would start. Okay. So if we apply everything to the negative 3 power, well, what's going to happen is we're going to have a power to a power. with power to a power, power to a power, because we have exponents that, or we have variables that are already being raised to an exponent. So similar to what we had over here, when we have power to a power, we have to multiply. So just kind of saving some space, we're going to have x to the -4 times -3 would give us a positive 12. Y, technically right now, to the first power, so 1 times -3 will give us y to the -3. And then z to the fifth, 5 times -3 is going to give us z to the -15. So that handles the applying the negative exponent. In our second parenthesis, we could just, for now, keep the expression as it was. And now we can look at combining. Again, before I would start moving, you know, a y to the -3 down to the bottom and making it and putting in the bottom of a fraction, as well as the z to the -15. Try to combine here left and right, because when we do combine, we might end up having positive exponents, which means we don't have to worry about flipping things down to the bottom. Okay, so looking at this and combining now, well, we have a 3 coefficient. There isn't any other coefficient on this in this parenthesis, so we can just put a 3 out front. And we want to look at our x terms together, x to the 12th times a single x. Then our y's, y to the -3 times y to the 6. And then lastly, z to the -15 times z to the 10th. Okay. So just combining each, and we should have our answer. 3 out front. X to the 12th times x to the, remember this is x to the first, so those we would add and give us x to the 13th. Y to the -3 times y to the 6, adding here, -3 plus 6 gives you positive 3, so we'd have y to the 3rd. So that's nice, that handles the negative exponent and we don't even have to worry about it. However, over here we do get a negative exponent when we add -15 plus 10 gives us z to the -5. So we can't leave the answer like that, unfortunately, because we do have that negative exponent. So we would have to take z to the -5, take that part and bring it down. Even though it's not a fraction yet, we're going to have to make a fraction now of the problem and put z to the -5 down below in the denominator of that fraction. So everything else stays in the numerator, but z to the -5 now has to come down below. And since we moved it now below, it becomes a positive 5 exponent. So that makes it look like we're sticking it in the numerator. We're actually coming down here, sticking it in the denominator. So if you have a negative exponent in an expression that's not a fraction yet, you have to make a fraction and then stick it into the bottom. If it already is in the bottom in a negative exponent, that's where we would have just taken it and moved it up to the top. Alright, and that will conclude section 5.1, all the exponent rules.